Okay, so in example 7, we're going to try to find the sum of a geometric series. Now, in the last video, I kind of glossed over why this particular formula is going to be valid to find the sum, and we're going to continue to gloss over it here. Just for one lesson, we're already kind of running long for the amount of videos we're going through here, so we'll save this for another time or for your own interest to kind of run down why this works. You can just play with it. You can multiply both sides by 1 minus r. You can move things around. Maybe eventually it would kind of pop out to you why this works. But for now, we're just going to use this formula. So this looks like a Japanese name. I think Kateri. Kateri wants to set up some dominoes so she can knock over 1, which knocks over 2 more, each of which knocks over 2 more, and so on. If she wants to make 6 rows of dominoes, how many will she need in total? Okay, so concept is that we are doubling the amount of dominoes that happen each row. So 1, 2, 4, 8, 16. We want 6 rows, so we need to know how many dominoes do we need to gather up to do this. Okay, first row has 1 domino, so A1 is 1, R is 2, and N is 6. So in this formula, we'd be plugging in 1 for our initial term. So we'd have 1 minus 1 times our rate of multiplying by 2. We want to get 6 rows total. So we have a 6 up here, 1 minus 2 on the bottom. Okay, simplifying all this, 2 to the 6th power should be like 64. So 1 minus 64 is going to be negative 63. 1 minus 2 is negative 1. Dividing this gives us that we need 63 dominoes total. So as long as we can kind of, just fill this in, don't need to memorize this formula, as long as you're comfortable taking this formula as kind of your structure to find these sums and filling them in, just knowing what A, 1, R, and N are representing. So they're representing our first term, which would mean that we have 1 domino to begin with. That would be what our first term is in this example. Our rate at which this is growing, so we're doubling, and the fact that we want to go out to the 6th row, so that means N is 6. As long as we can fill those in, then that is good enough for today.